you need actually, so if I draw a tangent to this very curve, okay, everywhere if I draw the tangent, what the tangent will give me? Can anybody? Tangent to this very curve, what it will give me? Slope. What is that? So this is a trajectory. The tangent to the trajectory will give me the velocity at that point. Is that true? Clear? So if you are having a line, if you draw a tangent, what it will give me? A derivative of that very line at that very point, is it? So what is the derivative of this very this way, of this trajectory at this point? So it is the tangent and that will give me the velocity. So this will be the direction of the velocity, is it? If it is the time-like event, it's an accelerated body, but a time-like event, what should be now this tangent? So, or the velocity should be less than velocity of light, is it? So this tangent should exist within where? Within the cone. Okay? So if I draw a light cone here, so similarly let's say you draw a light cone here, you draw a light cone here, you will see this tangent will be always within the light cone. Okay? Clear? Samajh? So only then you can have a defined trajectory. Clear? If let's say the tangent is outside the light cone, that means at that point you are in a space-like domain, is it? Because since tangent gives you the velocity, so the velocity exceeds the velocity of light at that point. Okay? Clear? Okay. So now let's draw the Lorentz transformations quickly. Okay, the home assignment will be draw the circular motion. Okay, if you are having a circular motion, a body is executing circular motion, for that draw the space-time diagram. Okay? Since we are considering only one frame of reference here, now let's take the Lorentz transformation, how the two frames look like on this space-time diagram. Okay? Okay, so what are the Lorentz transformations? So you are having delta x prime as gamma, delta x minus c, delta t. I am assuming actually finite separation. Okay, what is it here? V by c. V by c square. Is it V by c square? Okay, I will write it this way. Beta. What it is here? What it is? V here. Let me write beta c. Let's put c here. So it will be c here. So what it will be? V by? So it is simply beta. That's huh? Black and so it's not working. Okay, let's draw first. Okay, so this is our K frame. Okay, so let's call this as x0. Oh, sorry, x1, and let's call this as x0. Okay. Okay, now tell me what is the equation of this x1 line? What is the equation? When x0 is 0, you will get x1, is it? So this line you will get when x1 is equal to 0, so you will get x0, is it? Now let's draw, what I need to draw? A frame that's moving related to this very frame, is it? I want to draw that frame on this very coordinate system, okay? What I need to figure out? What is the x prime axis and what is the x0 prime axis? Clear? Is that what we are looking at? Huh? What I am saying, okay, what we are trying to do, we are looking at Lorentz transformations, how coordinates transform and how the axes look like. Okay, if I have to draw the two frames on this, at a single origin, okay, with the same origin, how they look like. Okay, one frame I know, is it? So let's start with one frame. This is our K frame. When I move now, so you will be in the K prime frame where the coordinates are given like this way, is it? So I am taking only these two coordinates because I am assuming boost along x direction, okay? Now what I need to find? I need to find what is the x prime axis, I need to find what? The primary axis, primary coordinate axis. Is that true? Okay, tell me if I try to find, let's say delta x prime axis or the x prime axis. Let's try to figure out this x prime axis. So what that means? P prime should be 0 on this axis. Is that true? So look here. So if I have, what is the equation of this x-axis? When p is, okay, what are the points on this thing? So when x naught is 0, so this gives, it gives me this very axis. Oh, how I define this very axis? When x is 0, is it? It is clear. So if I need to figure out x prime axis, what I need to put? P prime is equal to 0, is it? So on x prime axis, I put what? P prime is, or in other words, Ct prime is equal to 0. Okay, so now let's look at this very transformation. So it means C delta prime, T prime is equal to 0. So what I will get? Okay, okay, let's put not delta, let's put simply this way. Okay? X naught. So it's x naught prime, so it's gamma. Let me write x naught minus beta x1. ठीक है? So let's put this way. Yeah? So let's look. So I need to put this x naught prime equal to 0. What I will get? Tell me. So I will get. So that means this object has to be equal to 0. Okay. So what I will get? So x prime x1. Sorry. Beta x1 is equal to x naught. Okay. What I am getting? Now tell me. X naught by x1, that's equal to beta. So what is x naught? So this is Ct divided by x simply. So what it gives me? The ratio of Ct by x should be, so it gives me what? Tell me. It gives me actually the slope of the axis. So it gives me the slope of this x prime axis. Okay? So what it is? Beta. Now look here, you are having time up and x down, is it? So that means this axis divided by this axis, it's equal to beta. Beta is v by c, is it? So that it is less than 1. Slope is less than 1. Why that is? So this axis will fall. So let's assume this is your time like axis. Sorry, this light like axis. So it will fall here. So this will be your x prime. Because this is the slope less than 1, is it? So समझ? Okay, forget this line for the time. Yeah, everyone समझ? So this will be x prime axis. Eh? So let's write this is x1, but in a primer system. Okay. Now let's take which axis? Let's take time axis. Okay. So that is Ct prime axis, or which axis? X naught prime. Right? So what is that? X naught prime. So I will be having x1 prime, that's equal to 0. Clear? So what we will get? So I am getting x1 is equal to beta x naught. What is that equal to? x1 by x naught is equal to beta. So it is x1 is what? So it is x divided by Ct. So it is now Ct x by Ct, that's equal to beta. Okay? Tisha? Beta is less than 1, is it? Aisha? Yes, beta is v by c and v is less than c, is it? Okay, so what it is? X by Ct. Now it is this axis divided by this axis. Why that will be? It will be like this thing. Okay, so this will be x naught. Now look here, these axes are actually come closer. Eh? So now if you see, the Lorentz transformations are not orthogonal transformations. Is it? So you see, these two coordinate systems are not orthogonal to each other. They subtend certain angle here, depending upon the velocity. If you are having velocity, okay, let's say if the observer moves at the velocity of light, what will happen to these axes? They will go to the light-like line, is it? Both axes will go there, is it? So, samajh clear? So, samajh if let's say they are moving very, very slower, so they will slightly move like this downward. Okay, so this will come down, this will move here, but they will not exceed this way. Samajh clear? Everybody got it? So this is these are two frames. So this is the primed frame and this is the unprimed frame, okay, which are related by Lorentz transformations, okay. So you can extrapolate these lines like this thing, this way, okay. So you can extrapolate this fashion. Clear? Now the point is that I have figured out this very frame of reference. Now if I take, let's say, unit length on this axis, this very axis, because I need to calibrate the curves, is it? So if you, so on this plane I am drawing these as lines, but if you look this in the three-dimensional space, these will be actually planes, is it? So this will be a plane, this is a plane, okay? So this will be actually a smaller cone, a cone embedded in this very cone, is it? Otisha? Is that true? Okay. Now what I need to do, I need to actually calibrate the axis. If I know, let's say, I can put the units on this very axis, is it? But these coordinates are related by Lorentz transformations with these very coordinates. That means the length which is defined on this very coordinate will not be same here, is it? We are having two effects, time dilation and length contraction, is it? Because space and time coordinates get mixed, it does not mean if you are having a unit length on this very axis, it is same unit here, is it? I need to calibrate them. How much they are different. Clear? Or if you are taking a unit length on this very axis, how much is it here? Okay, what is the unit corresponding to a unit on this very axis? If I take a unit length here or unit time here, how much time is that on this very axis? Clear? So this will specify me the units. Clear? Okay, now let's write these things. Okay. Now let's take a length unit time on this very axis. On this very axis. So this is the origin. Okay. So let's take a unit here. So this is equal to 1. So I am taking an event which is what? Which exists on x0 line, not on x1, is it? So that will give me actually the length of this very coordinate. Although it's a time coordinate, it will give me the length. Okay, so what is the event here? So tell me what are the coordinates of this event here? So I am taking this as unit. What are the coordinates? So it will be, so first is x0, okay, x0 prime is equal to 1 and x1 is equal to 0. Tisha? So x1. Or let's say x. Let's say this way. For simplicity, you are having here ct prime is equal to 1 and x prime is equal to 0. So this is the coordinate. This is an event. Now let's look at the length of this very event here. Okay? How much is that? So what I need to do, I need to draw a projection. Is it? How I draw the projection? That projection should be parallel to this very line. Is it? So I need to draw the projection parallel to this very line. So this will be the projection. So I need to calculate how much this object is. Clear? Okay. Can anybody guess? So x prime is equal to 0. Go to the Lorentz transformation. Okay, you are having x prime is equal to gamma x minus vt. Is it? Oh, Isha? So let me write v by c, c into t. Clear? Isha and ct prime is equal to gamma into ct minus v by c square x. Isha? Is this the case? Sorry, v by c. It will not be v by c. Now tell me what is our x prime? It is 0, is it? So this x prime is equal to 0. What it yields me? X is equal to vt. Or I can write x is equal to beta ct. Simply, because beta is v by c. Clear? So now let's look at this very way. Since ct prime is equal to 1, that is equal to gamma into ct minus v by c x. So v by c is actually beta. beta into x. What is x now? So it's gamma ct minus beta. Okay, x is equal to, so beta ct. So it is beta square ct. Okay, so you can take gamma into 1 minus beta square multiplied by ct. What is that equal to? Can anyone tell me? 1 minus beta square is 1 by gamma square. So it is how much? So it is 1 by gamma ct. So how much is ct? Ct is equal to gamma. So 1 minus beta square is 1 divided by gamma square, is it? So how much is this thing now? So this is equal to gamma, is it? So now tell me, what is gamma? Root of 1 minus v square by c square. Sorry, 1 divided by 1 divided by. Okay. Now tell me, if velocity is less than velocity of light, this is small, is it? So gamma is greater than 1. Is it? So that means the length, the time coordinate is how much? Greater than 1. Okay? So it will depend upon, let's say, if you take, let's say v is equal to 0.5 c, is it? So you can calculate how much will be that. So corresponding to a unit will depend upon how you choose the velocity, is it? So if you choose, let's say, velocity v is equal to c, so what it will be? It will be infinity, is it? Okay, but if you choose, let's say, v near to c, so this will accordingly go as large. If v is, let's say, 0, let's put v is equal to 0, how much is that? It is equal, huh? If v is equal to 0, it is equal to 1, is it? So what is that? Body is at rest. So there are no relative motions involved. That's why you will be having same time here and there. Okay? Clear? Now what we need to figure out? So we have now figured out a unit on this primal coordinate is not same as the unit. Clear? So it is larger. What effect it is known as? Wait, because we are looking at the time coordinate. It's time dilation. Okay? So the time here is very large and here it is what? Small. So so that is the moving clocks are moving what? Slower. Okay? So now let's take the unit here on this very frame. What is the unit here? So this is equal to 1. Huh? So let's take ct prime is equal to 0 and x is equal to 1. X prime. Okay? So this is the coordinate. So how I will draw? Huh? Okay, so how should be the projection? Tell me. I think I have drawn the wrong projection, probably. I think it should actually, I am drawing actually projection from here. So it should be actually a parallel line. It should be actually a parallel line. Okay, let's draw a parallel line to this very thing. So let's draw the projection. Is that what I am saying? So, am I in a confusion? Okay, so let's write, first let's write how much is this thing? So this very object, the x on here, so it is beta gamma. Is it? So x is equal to, where is that? So this object is actually beta times gamma. Is it true? Yes, ct is equal to gamma, so it is, so ct is equal to gamma, so it will be beta gamma simply. Yeah? So this much is beta gamma, this kind of projection. Now let's draw the projection here. So I think I should draw a parallel line to this very thing. So, am I correct? Am I correct? First tell me, am I correct? What we are doing? Okay, what we will do it this way. We'll take a unit here. We take a unit length here instead of here. We'll take a unit length here. Ct is equal to 0 and x is equal to 1. We'll take a unit length here and try to check with this thing. Okay? So then I can draw a line parallel to this very line. I am correct. So let's try a projection to this very line. So this is the point what I am trying to figure out. So you put on your point you open here. So let me take this. So let's draw the projection. So I need to figure out how much is this very objective. Okay? So let's extrapolate this very thing. This very thing. Diagrams again is okay, but it will suffice. Okay. So this is the point we are taking, and we are looking it at here. How much is this very axis? Can you tell me? So it's not a good diagram. Huh? So it is. So I need to figure out this much. First, I need to figure out this much. How much is that? Can you tell me? So when I am taking CT is equal to 0, what I will get? Look here. Put CT is equal to 0. What you will get? X prime is equal to gamma times X. Is that true? So what is that equal to then? So just calculate. So tell me. You put CT is equal to 0. How much you will get? What is okay? So you put CT is equal to 0. How you will get? So X prime is equal to gamma times X. Now from here, if you put CT is equal to 0, you will get CT prime is equal to minus gamma V by C. That is beta X. Is that true? Is that true? So now let's write this as, so minus gamma beta. What is our X? So it is X prime by gamma, is it? So, am I saying correct things? How you calculate the other thing? Yeah, one object is 1. X is equal to 1, sorry. So it is simply X into 1. Because I am taking X is equal to 1 here, okay? Tisha? Is it clear? By the way, everybody is following it? Huh? So look here, I am taking X is equal to 1, that's why I put 1. So X prime is equal to gamma. So this very object is what? So this much is gamma. Now tell me, what about this coordinate? How much time is there? So time coordinate, it is minus beta gamma. So that is, so beta gamma, magnitude will be beta gamma. That's why it is here, extrapolated. Samajh? Now look here. So you have defined a length here, and this is, gamma is greater than 1, is it? So what you are observing? So you are observing, let's think you are observing a moving rod. What will happen to that? There will be a length contraction, is it? Samajh? So that's exactly this thing. So this is actually greater and this is smaller. Samajh? Clear? So you got my point. Similarly, okay, you can do it the other way around. There is no problem. Huh? In that very case, then what you have to do? Actually, if you do the other way around, you have to again draw the perpendicular projection. Okay, because I have drawn a parallel projection to figure out coordinate on this very axis and the coordinate on this very axis. Okay, so that is how it is done. Now let's take quickly the time dilation. So, how much time? Let's take time dilation quickly. Okay. So now you have, so sorry, this is not working, this pen. So just give me. So you are having time dilation this way. So now you are having two axes, like this way. So what? Okay, what do you mean by time? Okay, let's forget about this very primer frame. So this is your. Let's write this as CT and this is X simply. Okay, forget about X, not anything. X. So what the time dilation means? So moving clocks get slower, is it? So I will draw. Let's say my clock in one frame it's at rest, is it? So that means what would be the trajectory? So let's say in one frame, let's say my clock is in this K frame. What will be there? What will be the trajectory? It is a line parallel to x naught axis, is it? So it is at rest there. So let's write that. So let's say you are having an event A here. You measure, let's say, time difference between these 2 points. Okay, and you check what is okay. So you are having, let's say, C delta t is the time here. Okay, let's say this is the C delta t. Okay, delta t simply. This is the delta t. What is the amount of time you measure in K frame? Okay, now let's check in K prime frame. Okay, So what I need to draw? Let me draw the K prime frame, because let me draw the axis this way. Okay, one point with this way. You can draw this point here, there is no problem. Huh? So just for simplicity, I have drawn this point on this way axis. Now what I need to do, let's draw the projection here and projection here. How much this is? So this is your delta t prime, is it? So this is the amount of time on the primate frame. So this is x prime and ct prime. Okay, now tell me what is delta t prime? Yes? So this is, okay, so this is a larger thing, is it? Is this larger thing or this is
Delta t.
Delta t is larger, is it? And this delta t prime is smaller, is it? Because the time what we have seen here, so this is okay, this is actually gamma. If I take a unit time on this very axis, you will be having a gamma here, is it? Or here I am having gamma already here, amount of, let's say, this very thing. So this very object will be larger than this thing. So you are having a moving cloth going slower down. Huh? Similarly, you can draw. So this is your time dilation. From Lorentz transformation, you can then calculate how much is that. Huh? So, but I have just shown a diagram. Yes? हाँ बता. कोई problem है? No, everybody has got it. नहीं उस बकवास आशुस करना सारे ने वास समझ? Can? हाँ? Everybody is following? Okay, good. Now let's draw the length contraction. What a length contraction means? Huh? So you assume, okay, you assume a rod, okay, of certain length, is it? So that means you need to figure out the endpoints of the rod, is it? Let's take the endpoints of the rod here. That's for the, so these are the two events, okay? So this rod is moving, is it? So what is the trajectory of this endpoints? So this will be parallel to what? Time axis, because endpoints you can, so in your frame it's at rest, is it? And you are observing it from a moving frame, okay? So endpoints will follow this kind of trajectory. Now let's draw the primate frame. Okay, so you can see, so this is your A prime and B prime. So you are having, let's say the rod is having, this is the let's see. So this is the length of the rod. So this point. So this is your delta L here. Eh? So what this is? Delta L prime. Okay? Clear? Okay, so this is how you can manipulate. Okay, now home assignment for you people is draw the space-time diagram for twin paradox. Okay? Just do, okay. So twin paradox. Second is relativity of simultaneity. Okay? So draw their space-time diagrams. You and the order of events. Order of events means, okay. So let's say in one frame of reference, one event occurred at time t1 and another event occurred at time t2. Now if you are observing from another frame of reference, when they will occur, the order of events will be changed. Okay, I will tell you, okay, let me point this, okay, to you. So if you are having time-like events, okay, since all the time-like events are causally connected, so it means an initial event will occur first and the later event will occur later, is it? But if you are having space-like events, so they are all causally disconnected, so you can change the order of events for space-like events, okay? So let's say if you are having one event occurring at time t1 and another occurring at time t2, the space-like events, you can change the order, Got it? Because they are entirely causally disconnected. But all time-like events are causally connected, so it means the order of events follows. Clear? Okay. So let's, since we have done all these things, let's do the kinematics of the particle. So that will help us to understand actually the four velocity concept. Because we need to figure out, yes, we need to figure out the velocity of the particle. We have defined the trajectory, is it? When I define the trajectory, okay, so I need a parameter which will specify me the parameter trajectory. Let's say in simple mechanics, when you have a trajectory defined by x, you say it's x of t. Time serves as a parameter, is it? Okay. So we need to figure out that kind of parameter here. What is the parameter I can choose? Yes.
Is delta L prime greater than delta L?
Delta L prime is greater than delta L. Yes.
So how is it length contraction?
Wait a second. While we are observing,
In KD.
huh?
K prime frame.
We are observing it in K frame. So you have to put it in actually the reverse order. This very diagram. We are observing it in moving frame. Okay. So there is actually you need to look it carefully. This very diagram. Okay. So if you are still not able to understand, I can. So but you need to look at carefully. Okay. So are you satisfied or not? Are you satisfied? So let's say if you are having a rod, so how much is the length? Okay, let me write. How much is that? I should have put that. So you get actually this is the amount. So on x prime delta x is some x prime is equal to root of 1 minus v square by c square. So you'll get from. Okay. So what is our, okay, let's write these transformations. You are having delta x prime is equal to delta x minus v square by c. What is that? What is it equal to? What are the transformations? I forgot. X minus v delta t here divided by, okay, so you are having gamma here, and then you are having how much? Delta t prime is equal to gamma delta t minus, what is here? V by c delta x. Okay? Is it v by c square? Yes, v by c square. So now you can calculate how much you are having delta t prime is equal to 0, is it? In primary coordinate system. So how much you calculate? Delta t will be there. If delta t prime is equal to 0, delta t will be simply v by c square delta x. Okay? Clear? So now let's substitute delta t in this very case. How much you will get? Delta x prime. So you substitute for delta t, you will be getting v, it is v square by c square, is it? Times delta x, you take it out, so it is 1 minus v square by c square. So that's 1 by gamma square, okay? So how much will be that? So that will be simply delta x root of 1 minus v square by c square. Because in the denominator it will be gamma. So that will be simply root of 1 minus v square by c square, okay? Clear? Huh? So it's actually, from the diagram, it's sometimes, you need to look carefully at the diagram. How much is it? Okay, you have to calculate it from actually Lorentz Transformation itself. Okay, so this is the formula for the length contraction. Okay, delta x is the length where? It's in the rest frame. Okay, so you are observing it in the moving frame. Okay. Got it or any confusion? Okay, good. Okay, so let's take, now what we have done till now. So in this lecture what we have done, if we are having ds square greater than 0, less than 0 and equal to 0. So this is what? Time like. This is space like. Let me repeat. Okay, so this is light like. Now if I take a 4 vector, let's say I am having a 4 vector. Let's say A mu. A mu is a 4 vector, or let me write small a mu, because A we will be using for the potential. Let's write A mu as a 4 vector, okay? If now the length of this 4 vector, okay, the length of the 4 vector can be either greater than 0, less than 0, or what? Equal to 0. So if I am having A mu, that is same as what? A square. If that is equal to, let's say, if that's greater than 0, less than 0, equal to 0, I call it as a time-like vector, and we call this as a space-like vector, or we call this as a null vector. Okay, so this A mu, I can write like this thing: G mu nu A mu A mu. Okay, simply I have raised this mu index, one of the index I have raised it with the G. Clear? So, समझ आवा?